All right, so let's learn some new postulates that'll make proving triangles congruent a lot easier, because instead of having to show 6 sides are congruent and instead of having to show 3 pairs of angles are congruent and 3 pairs of sides are congruent, so all 6 things are congruent, we now narrow that down to 3. So we're going to do over two postulates today, the side angle side congruence postulate and side 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 congruence postulate. So let's actually write this down first, and then we'll look at what it looks like with the diagrams. Okay, so this side angle side congruence theorem tells you exactly what you need. You need 2 sides and an angle. What's special about this is it has to be 2 sides and their included angle of one triangle, and 2 sides and the included angle of another triangle. They must be congruent. So you want to make sure you write that down. And let's take a look at what I mean by included angles. Let's go ahead and call this triangle ABC. And then the second triangle XYZ. All right, so you need to be given, again, 3 things to show that to conclude the triangles are congruent. So again, 2 sides and the included angle. So for example, if we say we are given AB is congruent to XY, that's one part, right? All right, so that is one pair of sides. We could also be given that BC is congruent to YZ. So those are my 2 sides, the S and the S. But notice how the A is sandwiched between it. So when we talk about the included angle, and we talk about this included angle right here, we're talking about the angle that's right between the 2 sides. So the angle that's basically formed by the 2 sides in your SAS postulate. So again, what we need to see is that this included angle Y is congruent to the included angle here for ABC, which should be angle B. So if we were given that angle B is also congruent to angle Y, then we can conclude that triangle ABC is congruent to triangle XYZ by the SAS congruent postulate. All right, I put congruence here because next trimester we're going to talk about similarity. So I like to differentiate between congruence and similarity using that symbol. So that's why I put that there. All right, but again, the key thing with the SAS postulate is knowing the included angle. So think about why we can't say the triangles are congruent if we were given, for example, angle A and angle X instead of angle B and angle Y. All right. Next up, we have our side-side-side congruence postulate. So this one, hopefully pretty simple. You have the 3 things you need, all 3 sides. So let's go ahead and again write this down first, and then we'll look at the diagram. Okay, so hopefully this is pretty straightforward. It's in the name, right? Side, side, side. Basically, 3 sides of one triangle have to be congruent to 3 sides of another triangle. There's no getting around that. If we have those 3 things, then our triangles are congruent. So once again, you're looking for 3 things. Let's call this triangle ABC again. And let's call this one XYZ. And again, you need to show that 3 sides are congruent. So I could tell you, well, AB is congruent to XY. That's 1. Okay. Then you'd also need to know, for example, BC is congruent to YZ. That's 2. Oops, let me put that segment line on top here. And then the third thing we need to know once again is that final side for SSS. Okay, so AC is congruent to XC. If we have these 3 things, then we can say triangle XYZ congruent to triangle ABC by SSS congruence. Okay, so those are the 2 we're going to focus on today. Really look at what you have to be given. So again, it's 3 things, but you want to look very carefully. Are we given the included angle? Are we given all 3 sides? Before you can say yes or no. All right, let's take a look at example 1. And this is a good example with 3 diagrams showing us, well, are these triangles congruent or not? And really challenging you to see what you know. Okay, so let's take a look at A. What do we think? Can I use SSS or SAS? I think in A, very clearly, SSS is not going to work because I don't have enough information for all three sides. But what's interesting here is I know something about this line segment in the middle. Does anyone remember what this property is called when they share it? Hopefully you caught that. This is the reflexive property, right? So they're congruent by the reflexive property, which means I've got side, angle, side, right? Side, angle, side. So yes, by SAS congruence because we've got this reflexive property. So I'm starting this right here. You need to make sure for this type of problem, you include that in your justification. So this is the tricky part. Look for those reflexive sides, right? Take a look at B. What do we think? Can I use SSS or SAS here? Well, hopefully you're seeing I've got no information about angle bisectors or congruent angles, so SAS is automatically out. But you also see this once again, we share this side here, which means we've got the reflexive property once again. So that's congruent by the reflexive property. And once again, remember, you need to have this in your justification, in your explanation. So since it's congruent by the reflexive property, I've got congruent sides here, congruent sides here, and a third congruent side. So yes, by SSS congruence. Okay, take a look at C. Remember, think about what you need to know. Find my duck, my neighbor just came home. So again, think about what you need to know for SSS and SAS and if it'll work. So if I look here, I've got a pair of congruent sides. I've got a pair of congruent angles, right? No information about the other, these sides out here, so probably not going to be SSS. Since I have an angle, I really want to try for SAS. So once again, let's look for that reflective side right here. So I've got this reflective middle side, but look at this carefully. Does it follow SAS for both of the triangles? Hopefully you're seeing it doesn't, because for this angle to be included on the left triangle, we need this to be the other side, right? Since we don't have any information about this side, we can't say the triangles are congruent. So again, that side needs to be congruent for it to be included, because this angle A right here that I labeled A right here, it's not touching this S at the bottom. So this one was a tricky one. This is no, because the congruent angle of the left triangle is not the included angle. Right? So that one's a bit tricky. If you have questions on that, definitely ask in class.